Hello everyone. In this video, I'm going to talk about the concept and nature of OSPF version 2 DR and BDR for multi-access networks. This is still under module 2 of the ENSA curriculum, the new version 7. All right, so let's get right into it. Let's discuss what is the nature of this multi-access network. All right, so OSPF DR and BDR. DR here stands for designated router, and BDR stands for backup designated router for multi-access networks. Now, multi-access network is a type of network that uses OSPF network, and this is a unique in that one router controls the distribution of LSAs or link state advertisement. As you can see in the topology, the four routers are connected to a common broadcast device, the switch, and it causes a problem of LSA flooding. So this is actually what is actually happening in multi-access network. Each device in a participating in a routing domain sending their LSA throughout the network. All right? So it becomes chaotic. All right, so that is why in multi-access network, they develop a concept of electing a DR or designated router and BDR or backup designated router just to solve the problem of LSA flooding in this multi-access network. That is actually the problem in this kind of network, this type of network. The LSA floodings becomes excessive. All right? Now, the concept of election or electing DR and BDR is the solution for this problem. There must be one device that will act as a DR or designated router that will collect and distribute all the LSAs of all the routers participating in the routing domain in order to control the routing processes of all the routing processes, at the same time controls all the updates or the LSA coming from the different routers that participated in routing domain. And there's also a BDR. Now, this concept is very important because, as I said a while ago, this is supposed to be the solution of having this kind of problem of LSA flooding. So this is a multi-access network topology that we're going to use. If you notice, these three routers, R1, R2, R3, are connected to a common network, 192.168.1.0/24. And it was assigned a router ID. Usually, router ID is being assigned as the 32-bit dotted decimal. In this case, R1 denotes R1, so the RID you can assign is 1.1.1. If you're going to use R2 as your host name, we can use router ID as 2.2.2. that is an IP version format that requires for the assignment of router ID. So we're going to see later on what is actually happening in the configuration inside each router. Okay. So I've shown you a while ago the nature of the problem of the multi-access network, that is LSA flooding. Link state routers flood their link state packets when OSPF is initialized or when there is a change in the topology. So when the router initializes, it will send its link state address or LSA to the network. And if there's a change in the topology, there's this will also be part of the updates, and this will be sent also to a multi-access network. That is why in multi-access network, the flooding become excessive, as I said a while ago. So the solution for this is they have to elect a designated router, or the DR, where the DR is to have a central collection and distribution point for LSAs that will send and receive the LSA, the link state advertisement. And the election of backup designated router as well is very important, because in the case that DR will fail, backup designated router will act as the designated router. So in all the routing domain, all other routers that is not elected as a DR or BDR will become DR others. Okay, so this will be the main solution for this LSA flooding, electing DR and BDR. Now, these are the important information that you have to understand in the election of DR and BDR. The DR others only form full adjacencies with DR and BDR. So those who are not elected, those routers which are not elected as DR and BDR will become DR, but they will form full adjacencies, neighbor adjacencies only to DR and BDR, and not to other DR others. Okay? And the DR others send their LSA only to DR and BDR. All right? And DR other will use 224.0.06 multi-access address to all DR routers using the 224.0.0.6. Now, in the case of the topology, R1 send LSA, if you notice in this topology, it is obvious that the DR will be the router number 3 because it has the highest router ID of 3.3.3, and the BDR is the router 2.2.2. Now, R1, in this particular scenario, R1 sent LSA to DR and BDR. Okay? Since R1 plays a role as DR others, this router will send LSA to DR and BDR. Now, the DR is responsible for forwarding the LSA from R1 to all other routers. So once the DR receives the LSA of R1, it will forward it to the other routers that is participating in the routing domain. And the designated router use the multicast address of 224.0.0.5. Okay, all OSPF routers. So that is the difference. DR others use multicast address 224.0.0.6, and the DR use the multicast address to send and receive packets using 224.0.0.5. So this is the result. The result is that there is only one routing doing all the flooding of all LSA in the multicast network. So electing a DR will result into a more efficient way of sending LSA, because there is a one router that acts as a DR that will collect and distribute LSA to other routers that is participating in the routing domain. So only one router is responsible for that, instead of having instead of all routers sending their LSA to each other. It will result to a chaotic network sending of LSAs, and it will be excessive. All right, so moving on. So how does DR and BDR election, or what are the criteria of electing DR and BDR in a multi-access network? Where the first criteria is, number one, the router with the highest OSPF interface priority will be the DR. Okay, please take note of that. Router with the highest OSPF interface priority will be the DR. And the router with the second highest OSPF interface will be the BDR. So if OSPF interface priorities are equal, the highest router ID will use to break the tie. Because all routers, Cisco routers, has a default priority, interface priority of that is equal to 1. So therefore, if all the routers participating in the routing domain has a priority 1, that's the time the router ID will be used as the basis for electing DR and BDR. It is used to break the tie, the router ID. So in the case of the three routers, as I have shown you a while ago, router 3 has the highest router ID. That is why it was elected as the DR. And the second highest will be the second highest router ID is the R2. So it was elected, assigned as BDR. So if you want to know the status of the DR and BDR, you can use the show IP OSPF interface, and then the name of the interface or particular router. Verifying OSPF neighbors, you can use this command, show IP OSPF neighbors. So we're going to use this one later on in our demonstration. Now, timing of DR and BDR election, this has happened in real scenario. So apart from the process of applying the criteria of electing DR, BDR, actually, the actual scenario is if a router has booted first and started the election before the others were ready, this router would be the DR. So in the three routers that I have shown you a while ago, whichever router you will configure first, even if that router has a lowest router ID, that would become the DR. This is a very important notes that we're going to I'll be showing you later on. The election criteria was not being applied. So whichever router you will configure first or booted up first, that will be the DR, even if the router ID is the lowest. Okay, so next, the DR and BDR election process takes place as soon as the first router with the OSPF enabled interface is active on the multi-access network. So that is what actually happening once you turn on the router, and as soon as you turn on the process, as soon as you turn on the router, it will start the election process. So whoever the router turns on or activates, that will be elected as DR or BDR. Okay. This could be a lower end router that took. So most of the time in real scenario, the router that has a lower end capacity, that means it boots, or the booting process took less time. So therefore, the lowest or the lower end router, if you configure it in an OSPF routing protocol, that will be the DR. And then the higher end router will be the BDR or DR other. So these are the scenarios that is not actually breaking the criteria of electing the DR and BDR. So I'm going to show you this one. Without the election, without the process of election, the router in a multi-access network is actually electing automatically based on these following scenarios. Okay, number one, if you booted the router first, even if it has a lowest router ID, that would become the DR. And if the router's process takes place, the election process takes place as soon as the first router is enabled. Router with an OSPF enabled interface is active on the multi-access network, that will be the election of DR and BDR will takes place. And the third is the lower the processing, the lower the specification of the router is, the higher the chances of being assigned as the designated router. So these are the three scenarios. That is why the election process is kind of automatic in multi-access network. Okay, so let's move on. Now to influence, or in order to avoid this scenario to happen, we can actually control the election. As a network administrator, we can actually control the election process we can choose whichever router we want to be a DR or BDR. Okay, so as an administrator, you can control that one just to avoid the automatic assignment of DR. So these are the following things that a network administrator do in order to influence or control the election of DR and BDR. Number one is the interface priority. Since all the Cisco routers have a priority of 1, they have equal priority, the network administrator can manually configure the priority number of a router in order for that router to be elected as DR BDR using the command OSPF priority, and then select the process ID of 0 or priority number 0 to 255, and 255 is the highest, 0 is the lowest. Now, as a network administrator, if you want to control the election of the RBDR, or if you want to select, it is very important for you to consider that the router has a sufficient CPU excuse me, memory capacity to handle the responsibility. Do not assign a DR having a lower CPU and memory capacity. Because if you remember, DR is the one responsible for sending the updates or the LSA to all the routers. Control the election of these routers with the IP OSPF priority interface command. So we should also remember that the highest priority wins. So therefore, if you want the router to be the BDR, we should assign the highest priority ID, which is 255. And if you want that router not to be elected as DR and BDR, if you want that router not to become DR and BDR, you have to assign a priority number 0, okay, and 1 as a default. So once you turn on the router, the default priority is 1. So if you want to make the router DR, as much as possible, use the highest priority ID, which is 255. Okay. So allow a router to be DR in one network and DR other in another by using the command IP OSPF priority by setting the priority number higher number. If there is no DR or BDR, if there is no DR, the BDR is promoted as DR. Okay, so that is the actual theoretical basis for electing a DR. If the DR fails, automatically BDR will assume the responsibility of the DR. Manipulating the election process, as I said, manipulating, that means you are manually controlling the election by manually configuring the router to be the DR. So the DR and BDR maintain the roles until they fail, even when more routers with a higher priority show up on the network. So this is the important concept here. Even if the routers having the role DR fail, the new router that is added in the network with a higher priority will not or cannot be a DR. Okay, so in our network a while ago, we have 3 routers. If you add another router to that particular network with the highest ID, it will not preempt to be elected as DR, even if the DR in the existing network fails. Okay, so that is one important concept that has to be remembered. So to influence the election of DR and BDR, do the following. So it was discussed a while ago. Boot up the DR first. You have to configure the router first, then it will be the first, that will be DR. And the second router you configured in the multi-access network, that will be the BDR. And then boot all other routers. Or you can also influence the election by shutting down the interface on all routers, followed by no shutdown on the DR, and then BDR. And then all other routers. So if you want the routers to be DR and BDR, you have to issue no shutdown command on its interface, and then reload all the routers participating in the routing domain. And another method to influence the election is clear the OSPF process. You have to reload or clear the OSPF process on the router. So I'll be demonstrating it to you later on. All right. So those are the concept that has to be understood in the multi-access network type network, multi-access type network. To control or to avoid the LSA flooding, we need to elect DR and BDR. In electing DR, we can, as a network administrator, we can control the election by setting the priority, highest priority number. And if we want the router not to be DR and BDR, we need to set it, the priority to 0. Now, without the configuration, without the actual configuration as a network administrator, you can do the influence, you can influence the election of DR by issuing no shutdown in DR and BDR that you want to be elected, and all other routers, and then shut it down. And all the other routers issue the command shutdown. Okay, so let's move on to the actual packet tracer. So this is the actual packet tracer that we're going to use. This is already pre-configured with the active interfaces and OSPF. And the router ID is already configured in this router. So let us see the information of in router 1, show IP OSPF interface. So in router 1, if you notice, router 1 has a router ID 1.1.1. And right now, the router 1 has a priority 1. Okay. And then the designated backup, the designated router, as shown in the routing table, is correct, which is router 3 with router ID 3.3.3. And then the backup designated router, based on the criteria, is the second highest router ID would be the backup designated router. Okay, so which is correct. If I'm going to check also, router show IP interface or SPF interface in router 2. Okay, so the same, it has a priority 1. And designated, the same, designated router is 3.3.3 and backup designated router is 2.2.2. Okay, so right now the correct election was happened in the routing process, because the designated router, in other words, they follow the criteria of electing which router will be the DR, and in this case, router 3, because R3 has 3.3.3 has the highest router ID. So, for example, I'm going to change the router ID of R2. Right now, R2 is the backup designated router. If I'm going to change this priority ID to 255, we'll see what will happen. So enable config T interface, that is interface G0/0/0. Okay, IP OSPF priority. This is the command, priority 255. Okay, and then in order for the changes to take effect, we need to issue the command clear IP OSPF process, and then reset all OSPF process. Yes, just click yes, and it will change the adjacency to other routers. Okay. So since this one has the highest priority, we change the highest priority, we will see if the existing DR will change, because the existing a while ago is the 3.3.3. Now since we changed the based on our criteria, priority, a router having the highest priority will be the backup, will act as the designated router. So let us see, show IP OSPF OSPF interface. So it was changed to 255 already. Okay. So if you notice, I changed the priority of the previous backup designated router. Then, as I discussed a while ago, the highest priority will be designated, will act as the designated router. If you notice, after changing the priority, the role of R2 now becomes the designated router, which is the backup designated a while ago. And then the backup designator, the designated router a while ago will become the backup designated router, which has a 3.3.3 router ID. So in other words, as a network administrator, you can actually control the election of DR and BDR. Okay? So if I'm going to issue show IP OSPF neighbor, these are the neighbor of R2. The neighbor is 3.3.3. It has a full adjacency, and the role is BDR. And this is the dead time interval with an address 1.3. Interface gigabit 000, and then the other neighbor is 1.1, having the role of the DR other. So the role of R1 now is DR other, and the role of router 3 becomes the BDR. Okay, after we change the priority ID to 25, to highest priority ID, 255. All right. So, for example, we want this R3 to be DR other. Right now, the DR other is the R1. Let's say, if I'm going to make the priority number of DR of R3, if I'm going to change, for example, the priority to 0. So we said a while ago, if you're going to set the priority to 0, that router cannot be elected as DR or BDR. It will become DR other. All right. So let's see. Enter config T. Let us change the priority in the interface G00 IP OSPF interface, OSPF, IP, OSPF priority 0. Okay, and then let us issue the clear IP OSPF process. Then hit yes to take effect the changes. So since we assign this as a 0, we are expecting that this router 3 will become DR other. Let us see, show IP OSPF interface. Okay, so let's check. Yeah, the priority now becomes 0. A while ago, it is 1. So let us see the role now. The backup designated router, the designated router now is still R2. And the backup designated router is 111. Okay, so it was already changed. It was changed already because the router 1 which has 1.1 router ID, this is DR other a while ago. Let us see what is the let's check in router 1, show IP interface, show IP OSPF OSPF neighbor. Okay, now let us see. Okay, so since the priority number is 0, the router 3 now becomes DR other. This is the role of R1 before we change the priority to 0. But now the DR other now is the router 3 because we changed the priority into 0. Okay, so that is how we change the router ID. How we can control the election of the DR and BDR. Okay, so let us. So right now the DR is the R2 and BDR is R1. And the DR is the DR other is router 3. Let us check if, for example, we are going to add a new switch. Okay, for example, I'm going to add a new switch here. So remember, our R2 is the DR, our R1 is BDR, our R3 is DR other because we changed the priorities to 0. Now if I'm going to add another switch to the another router to the switch, what will be, we said a while ago, the new participating routers cannot preempt the election. Okay, that means even if we are going to assign this router, let's say the router ID is 4.4.4.4, okay, even if this router has a router ID higher than the existing router ID, this will not preempt the election process as become the DR. Okay, let us see, let us configure the switch, add the router. So if I'm going to configure that router, let's say we'll make it, this is .3, .1, .2, make it .4 under 192.168. enable config t, and then host name R4, interface G0/0/0, invalid, why invalid? Interface G0/0/0. Why it is invalid? We'll check later on. Let's check the show IP interface brief. Show IP interface. So yeah, G0, GZ Gigabit Ethernet 0/0 only. 0/0. I used the wrong designation for the router. Router 4 should be config T interface G0/0. Yeah, and then IP address 192.168.1.4, 255.255.255.0. No shut. Okay. Let's see if the interface is now activated. Now let us configure to participate this router to a routing domain. So exit router OSPF 10. Okay, router ID 4.4.4, router dash ID 4.4.4, all right, and then let us participate in the network. Let us advertise the network 192.168.1.4, 255.25, wildcard mask. Since we are using the interface address, we can use subnet mask with quad 0, 1, 2, 3, 0.0.0.0, then area 0. And okay, yeah. Now let us show IP OSPF interface. Now the router R4 has a priority 1, and still the designated router is our R2, does not change, and the backup designated router is 111. Even if we have a new participating router R4 having a router ID of 4.4.4, it will not preempt the election. Okay. So for example, if our DR will fail, would the router R4 be DR? For example, this DR will fail. Let us disable the interface. We'll see. Enable config t interface. I think this is G0. G0/0/0. Yeah. Shut down. Okay, we shut down the interface. So that means router 2, which is the DR, failed. Which among the 3 routers remaining will be the DR? Because the DR failed. So by the basis of the criteria, this backup designated router should or must become the DR. Okay? So let us check. Let us check now. R1, show IP OSPF interface. Okay. Now the designated router now will be the router 1, which is a while ago, the position of this one is backup designated router. Now take note, the backup designated router now will be the R4. Why? Because router 3, we set router 3 as has a priority 0, and based on our discussion a while ago, if you configure the priority of a router to be 0, it will not participate in to become a DR and BDR. All right? So these are the scenario for the multi-access network of electing a DR and BDR. So there is no preemption, no preemptive action, even if there is a new participated routers having a highest router ID to a network. Okay? So I hope you understand these scenarios, okay, for this multi-access network under OSPF. So these 4 routers are OSPF version 2 enabled. So thank you so much, and we'll see you on the next discussion, the modifying the timers, hello intervals, and the dead intervals, and then propagation of default route. So see you on my next video. Thank you for watching.